Now, instead of vertex coloring, we're moving on to edge coloring. And so this is another item that will allow us to avoid conflict, especially with scheduling. And so let's take a look at our first example and then make some trends on what's happening. Okay, so you're a secretary for business and you need to properly schedule meetings for the day. There are 8 executives for whom you need to schedule meetings. Each meeting involves 2 of the 8 executives and who each talk to each other for an hour. The pairs of executives who need to meet are Lucy and Dylan, Lucy and Josh, Josh and Tim, Tim and Alan, Alan and Christina, Christina and Dylan, Christina and Bill, Bill and Mel and Alan. How many meetings are there in total? How can you represent the 8 executives mathematically? Then how can you represent the meetings that have to occur? All right, if we want to know how many meetings there are, we're just going to count and see how many pairs we've got. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 meetings. All right, so to represent those meetings, what I can do is build the relationship between each of those meetings, and then I can color the edges. So I'm coloring the lines in between. So typically when I do this, I start out with a really light pencil. In this case, it's a little bit difficult to do. What I could do is use kind of like a gray color. All right. So I have Lucy and Dylan. So I'm going to put a connection between Lucy and Dylan. In fact, let's see if I can go just a little bit lighter. Okay, I should be able to get just a hair lighter. All right. So Lucy and Dylan, I've got that going. That's good. Lucy and Josh. So Lucy and Josh are connected. Then I've got Josh and Tim. Josh and Tim. Tim and Alan. Tim and Alan. Alan and Christina. Alan and Christina. Christina and Dylan. So Dylan and Christina. Christina and Bill. So that connection there. Bill and Mel. And Mel and Alan. Okay. So what I can see here is I have a construct of all of these meetings. So if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, all of my edges represent the meetings. Okay, the pairs that are meetings. And then what I'm going to do is color each edge based on what's happening. And again, I'm going to go ahead and grab my highlighter here because it seems to be kind of an easier way to designate colors. So one thing, let's just dive into it. Okay, so Lucy and Dylan are meeting, so I'm going to give them a color of yellow. And so the time slot for Lucy and Dylan will be this 1 hour time slot. Well, then Lucy's also meeting with Josh, and they can't meet at the same time as she's meeting with Dylan. So Lucy and Josh have another time slot. Well, while Lucy is meeting with Dylan, Josh could actually meet with Tim. So I can go back to this yellow color, and those two can meet at the same time that Lucy and Dylan are. But Josh is involved in a green meeting, so I could have Tim and Alan meet at a green meeting. Okay. Then I have Alan and Christina could meet at a, oops, I didn't mean to put green there. They could meet at a yellow meeting. because Alan and Christina could meet at the same time that Josh and Tim do. And here's where I have to be careful. Dylan and Christina can meet in a green meeting because Dylan's already using Lucy's meeting at yellow, but he has time during the green meeting to meet with Christina. Now Christina's in 2 meetings already and she needs a third. So because there's already 2 different colors connected to her vertex, we're going to have to go with a third color. Okay, so you're not going to have any 2 of the same edges going into the same vertex. All right, so let's look at Bill and Mel. Bill and Mel could meet. They could also meet at a yellow time. So we can go back to yellow there. And then Mel and Alan. We already have Alan involved in a green meeting and a yellow meeting. So the only way that Alan can do a third meeting is at a third time. Okay. So one thing that we're going to list here is I guess we have another meeting. So there's 3 meetings there. So we have 1 hour, 1 hour, and 1 hour. So we have a total of 3 hours of meetings. All right. What is the most number of meetings you could schedule for 9 a.m.? Well, assuming that they start at 9 a.m., which I don't think it says, let's just assume that it starts at 9 a.m. We could go with our yellow color has 1, 2, 3, 4. The magenta has 2 and the green has 3. So 4 meetings would be the maximum. And then a set of edges in which no edges are adjacent. It's called a matching. I think there's something missing here. How can you represent the times at which they are to meet? Those are the edge colors. Okay, those represent the times. Find times for the remaining meetings to be scheduled. See the graph. We already did that. Okay, so this graph tells us what's happening. Does your schedule finish as early as possible? How can you be sure that you couldn't finish earlier? So we use the minimum number of colors for our graph. Can we schedule all of the meeting times in 3 hours if the number of rooms available is 3? Okay, so we have it in 3 hours right now, but we have that yellow as 4. Here's what we could do. Let me take a quick picture. If I take this, right, and if I swap this, I hit done there, save. If I bring this down here, can we schedule the meetings in 3 hours? Let's pull this in here. Okay. If we change one of our yellows to a magenta, then we can do it. So what I would do is just go ahead and and it doesn't matter if you change Lucy and Dylan or Josh and Tim. You can't change Bill and Mel, and you can't change Alan and Christina. So there's only 2 changes you can make. So I'm just going to change this first one. So if that's what we end up having, right, then we get that magenta color here. And then that would give us 3 yellow meetings and 3 green meetings and 3 magenta. Okay, so then can we do it in 3 rooms? Yes. And the way we did that was to change the LD meeting or the JT meeting to magenta. All right, so that is the start of our edge coloring. So let's go ahead and dive into some more examples.